Algebra 1, Arkansas Standard, LA1.A1.9. Add, subtract, and multiply simple radical expressions. A radical expression is an expression that contains a radical, such as the square root of x plus 3, which is read the square root of x plus 3. To simplify a radical expression, we remove the perfect square factors from the radicand. Perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on. For this radical expression to be in simplest form, the number 50, which is the radicand, may not contain any factors that are perfect squares. Well, as we know, 50 contains a factor that's a perfect square, and that factor is 25. So we're going to break this into parts. We're going to factor it out. And this is like the factor 50 factors into the square root of 2 times 25. 50 and 2 times 25 mean the same thing, so we can break it down as this. We can take it a step farther and we can say the square root of 2 times the square root of 25. Now the number 2 is not a perfect square. You won't always find both of your factors to be perfect squares. What we want is just at least one factor to be a perfect square, and that is 25. And we know the answer to the square root of 25. We know that that is 5. So my answer is the square root of 2 times 5. Now traditionally in algebra, we would write it so that this constant was in front of the radical sign. So you will see this answer written as 5 times the square root of 2. Let's go to problem 2. The square root of 45. The square root of 45 contains perfect square factors 9. Then 9 times 5 will give you 45. So I have the square root of 9 times the square root of 5. The reason that I want a perfect square as a factor is because I know its square root. And I know that the square root of 9 is 3. So the answer here is 3 times the square root of 5. Example 3, I have this constant 3 times the square root of 20. Well, I want you to think of this as a math problem. 3 times the square root of 20. That's what that means. It means multiply. 3 doesn't need to have any work done to it, but the number 20 needs to be simplified. The square root of 20 can be simplified. We can break that down into the square root of 4 and the square root of 5. The square root of 4, that's a perfect square, and I know its square root is 2. So I have 3 times the square root of 2 times the square root of 5. I don't know the square root of 5, so I leave it under the radical symbol. But I can go ahead and multiply these together, and 3 times 2 is 6. So this problem in simplest form is 6 times the square root of 5. Example 4. 2 times the square root of 32 plus 4 times the square root of 50 minus 3 times the square root of 98. We're going to break down each of these. When we're finished, we're going to combine like terms if possible. The first one breaks down into 2 times the square root of 16 times the square root of 2. Now, on this one, the square root of 32, I want you to look. You could have also broken it down into 4 times 8. But you would have had to broken 8 down as well, and it would have cost us another step. See, it would have been the square root of 4 times the square root of 4 times the square root of 2. So always choose the largest perfect square possible. Now we're going to continue on, and this is 4 times the square root of 25 times the square root of 2 minus 3. Now 98. 98 has a perfect square factor. It's 49. So this is the square root of 49 times the square root of 2. Now I'll go back and simplify. This is 2. The square root of 16 is 4, so I have times 4 times the square root of 2 plus 4. Square root of 25 is 5 times the square root of 2 minus 3. The square root of 49 is 7 times the square root of 2. Now I can multiply these constants. So I'm going to go back and have, this is 8 times the square root of 2 plus 20 times the square root of 2 minus 21 times the square root of 2. Each term has the square root of 2 as its radical part. That means they're like terms. If you have the same exact number under the radical sign, they are like terms and they can be combined. So I'm going to combine only the constants. 8 plus 20 is 28. Square roots of 2 minus 21 times the square root of 2. Now I can take 28 and 21. 28 minus 21 is 7. So the final answer here is 7 times the square root of 2. Last example. Example 5. 12 times the square root of 3 plus 5 times the square root of 48. There's not anything I can do to simplify 12 times the square root of 3. However, I can break this one down. The 48 will break down 16 times 3. So I'm going to rewrite this one. This is still 12 times the square root of 3 plus 5 times the square root of 16 times the square root of 3. Again, this one can't be simplified, but I can simplify this one. I do know that this answer is 4. So this one I'm just going to rewrite 12 times the square root of 3 plus 5 times 4 times the square root of 3. I can multiply these, so I'm going to have 12 times the square root of 3 plus 20 square roots of 3. Now remember, since they have the same number exactly under the radical, I can combine these terms. This is 12 and this is 20. Together that gives me 32 times the square root of 3. Oh, there's an example 6. We've got to do it. 3 times the square root of 18 plus 5 times the square root of 27. 18 needs to be broken down, so I'll break it down to the square root of 9 times the square root of 2. 27 can be broken down, so I'm going to have 5 times the square root of 9 times the square root of 3. So I'll go back. The square root of 9 is 3, so I have 3 times 3 times the square root of 2 plus the square root of 9 is 3, so I have 5 times the square root of 3 times the square root of 3. I can multiply here, and I'm going to have 9 times the square root of 2 plus 15 times the square root of 3. These are not like terms. The numbers under the radical are not the same. I can't combine these. This is the end of the problem. It's in simplest form.